So coming to SAP HANA, we have two types of storages of data, or two types of tables are there in SAP HANA. So one we call it as a row-based table, and another is known as your column-based table. So row-based and column-based, normally in Oracle databases, we find only row-based tables. There is no column-based tables at all. But from the existence of BW Accelerator, BWA, the SAP has brought up a new storage type, what we call it as a column store table. Say for example, when you see the files here, when you see the different types of files, now normally what happens is whenever you want to keep files, right? So this is the top one and there is one more in the bottom, right? So whenever you're trying to keep one more file, we'll try to put it in the bottom. But normally we keep on piling in the top itself, right? So if you want to add any file, it is very easy for us, right? Any new file comes up, you'll keep on top of this. Again, new file comes up, on top of this, you'll try to keep another file. So like this, we'll keep on piling the files. So inserting the data into this particular database is very faster. And for searching some common files, for example, I have some medical files, then medical file may be at this particular point also, or I can take a pointer here. So a medical file can be here, then can be here, can be here, can be here. If I have 1 million files, then the data can, this particular medical file can be in the first record also, or in the middle of this, or 1 millionth also. So I need to keep on searching from first to 1 millionth. So there are two things to understand. For inserting the data in a row store, it is very faster. But when you want to search the data, it takes some time to retrieve the data. But when you go for a column store, in the column store, what you do is we try to store the data in different columns. Like a Almira, you can see this. Say, for example, all medical files I'll try to keep in one particular shelf. Then all, say, for example, mechanical files I want to keep in particular shelf. So whenever I want to find it, so inserting will be taking some time, because initially if you want to put medical files, where is that particular rack, you have to find it and keep the files there. So insertion will be slower, but the aggregation, if you want to find the total number of medical files, then all the files will be there within the one rack itself, so that you can aggregate this very faster. But if you want to like a column store, if you want to insert this, it takes some time for this. So here retrieval of the data will be faster, but inserting will take some time. Okay, so that will be the difference between an row store and column store, right? No, if you see the data here, so this is your row store, and the data is how the data will be organized in a column store. So normally here, when you try to go for a row and column store here, now this is order, country, product and sales. Now if you want to find the sum of sales, then how the data, it normally reads sequentially. So this, try to read the data here. So 1000 again goes back to the second row, then again go for 900. So like this, it goes in a sequential way and get the sum of this, and we try to get it. So here during the travel, we see that a lot of unnecessarily columns also is red, which we don't require also. Fine. Now it goes sequential. But when you go for a parallel one, so column store data, okay, so then what happens is, whichever the data, now that particular column itself will be directly aggregated there, okay. So here we have sum of aggregation here. Fine. So now we have column store based data, right? And then after that, directly we can aggregate the data here. Now, if you want to see the actual storage of the data, so if you see this, normally in HANA, you'll be seeing like a table only, whether it is a row store data or column store data. The representation of the table and the representation of the data is same only. We don't find any difference. But in a row store data, when you're trying to store the data, for example, I have country, product and sales. Now country, then product and sales. This is the first row. Second row will be in sequential. Okay. The idea is it goes sequential. After that, again, in the hard disk, it will be stored normally like this in RDBMS. And third row, fourth row. So it always will be in sequential. Now, if you want to find the sum of this, then what happens is it has to keep reading this like this. Now, we are trying to go vertical. So India chocolate 1000 is found. Again, read this data also, this, again go for this, again go for this. So aggregating the data will take some time. Okay. Whereas in a column store, now the whole column data will be there sequentially written. After that, the product data will be the second sequence, and third is your third column, what you'll have. Now, if you want to find the sum of this, right, when you want to find the sum of this particular one, then it is very easy for us to do it than this. So whenever you think that when there are a lot of commits happening within a table, normally in transactional systems, then row store data is good. But when you have some millions and billions of data like big data, where we have a lot of social media data, we have last 5 years of production data or sales data. Now you want to aggregate and see the total chart from last 2-3 years, then right. So you're trying to read a lot of data. We don't want to read unnecessarily data like row store. So at that time, then we can go for a column store for analytics purpose, for reading purpose, aggregating the data directly for the column whatever is required, then we can go for your column store data. So the output of the data when you see in the system will be same, and when the row store also will be same. Only thing is internally when you have some more data, then the performance is the main thing what you will try to see it up. Okay. So this is the main core understanding between your row store and column store. Fine. So anything you want to have any clarification, any doubts? Because this is very important, because HANA, the main thing which is going to give the best performance, going to give the good performance for us is the row store and column store. Yes, anyone has any type of doubt?
HANA will support both row store storage and the column store storage also,
Yeah,
right?
both they have it. Now, depends upon the requirement. We need to decide whether we have to
Mhm.
create a row store or column store.
Is it possible to interchange in between?
Yes, we can change it, right? So we can alter the table. For example, by mistake you have done, or you thought that first it will be row store, then after that you want to make it as a column store. Yes, we can make that particular change. Right. Actually, today my server I did not start it. Right. So it is there in the office only. Then I did not go to office today. So still it is an off situation. I'll try to switch on in the morning, but today I'll try to use some temporary server. But today we'll have some theoretical and understanding. So tomorrow you can practice it. Not a problem. For example, HANA is a schema, and inside this I have some tables, and let me take, say, our sample table which we used last time. So let me go to orders, Control C. Now here, whenever you're trying to create a table, the first thing is what you have to do is just select this HANA schema, then click on this Open SQL. We can see here, this is HANA is your user which have been used up, and Control V. I'm trying to create one orders underscore T1. Let's take this as orders underscore T1. Create column table. You're trying to give this as create column table, and click on execute. So the table is created here. The same one, I'll try to create one more. So if you don't want to create a column table and you want to create as a row table, just give it a specify as row. Or if you don't want to specify the row also, just remove this. By default, it will be creating a row table. Orders underscore T2. I'll try to create this one also. Now, if you go for the orders table, you can see here that we'll be having two types of tables, orders underscore T1. Okay, still not done, then we need to refresh it. There are a lot of tables created here. Let me refresh the tables. So when there are a lot of tables here, then what I can do is just select this folder, tables folder, go to filter, and here you can give it as orders. Don't give star and all, because this itself will automatically put a star there. Then you can see all the orders table which are created here. You can see here there is a star and star which is automatically put. But if you prefix this again star and star, then data will not come down. Okay, so this is the best one. So we'll go for orders underscore T1 and orders underscore T2. These are the two tables which you created. You can see here, right? This is a column table. The diagram itself, the icon itself will show that this is a column table and this is a row table. Now, when I double click on this, you can see this, the type of table which will be created is column table, and this type of table will be a row table. But the structure of the tables both are same. Okay, for this table as well as this, the structure will be same. Now what I'll do is creation of table is fine. Then if you want to insert the data inside this, and we'll try to take the data from here. This is how you need to practice it, right? If people take a simple file, keep working with simple examples, that should be fine for us. Now Control F, search for orders, and replace this orders with orders underscore T1. Replace all. Okay. Now we'll try to insert this data into orders one table. Now it is done. And second, what I will do is Control F, orders underscore T1. I'll replace, I want to insert another into another table also. Orders underscore T2. Control Z, T1. Replace all. Now I want to insert into T2. Now click on insert. Orders underscore T2. Okay, the last one is having some problem. I'll see if this is going good. Okay, the last one is having semicolon is not there, and T2, let me take only a single one. Not a problem, but there should be data inside this. Yeah, this is also gone. So when I try to go for select star all the records from orders underscore T1 and execute it. So this is the output of the data. So 11 records have been retrieved. Now, when you go for the second table, that is orders underscore T2, now click on execute. The same 11 records has been retrieved. Got it? So orders 1 data and orders 2 data, the output display will be same, but internal architecture is different. Getting it? So because the reading sequence of your column store will be like this, whereas row store is going to become as this one, right? 1 minute. Cool. So now this is your row store and this is your column store. Okay, now let's go to the next one. So one more simple sample is, for example, I have arranged this particular, say for example, all your biscuits and other things in a grocery shop. And say for example, I want to find the total number of this cookies, or say for example, the total number of this, right? For example, some bickies. So 1, 2, 3, 4, 5, 6, 7 are there. Now, if you want to find the sum of this, then I can say 7 is the total count of this. It is easy to calculate, right? Because all this there in one particular column itself. But if I try to jumble this, all the things and all the items, and if I find out the number of items, if there are 1 lakh items, then I have to search from first to 1 lakh one also, right? Because it may be there in the last one also. We don't know like whether it is there or not. So we have to search from starting to ending. But if you try to arrange this in your columns, then it will be good there, right? Just a minute. Okay. No. So this is a sample data. Now, for example, when you want to find out, normally for the interview sake or somewhere, someone is asking what is the difference between a column store and a row store. So row store is going to store the data in tuple, in disk tuple by tuple. It is going to store record by record. And normally what is the advantage of a row one? It is easy to add or modify record, right? And but the disadvantages might read unnecessary records. So here I take this. So might read unnecessary data. All data in the rows has to be read, even though the requirement may to access data from a few columns in analytical processing. Okay, so I want only the first column and the last column. For example, I have some 5 columns. Like first is your plant, then storage location, then material group, then material, then your quantity. But I want plant and the quantity to be read. Plant wise the total quantities, and in between I don't want to read any data. Then column store data storage will always be good, because I want to read the first column only and the last column. But when you try to row store, then it has to read in a sequential way. Then after that it goes by tuple, and after that there is unnecessary reading of more data, and the more the time it takes up. And when you go for column store data, is the data is stored in columns. So there's a virtual, all right, but actual is same what I shown this image there. So it will be stored in columns, and columns store more input output efficiency for reading of queries and reading of writing of this. Okay, only reads relevant data, and we have better caching effects, better compression also, and partitioning of data is also good in column store. Okay, but the disadvantage is after your selection, selected rows has to be reconstructed from columns. Even your insertions or deletions, again you have to restructure your whole columns. Okay, and insertion on deletion always will be slower than your row store data. So for example, if there is a lot of 1 lakh transactions are happening within a second, say for example railways, now when you see for example when you're doing a booking at 10 o'clock, if a reservation starts at, then everyone will be logging at the same time and doing a lot of transactions within a second itself. So at that time, column store is not good. For that, we should go for your row store data. But analytical purpose, whenever you want to read the data, not write the data faster, then you can go for column store data. Okay. So this is how we try to see this. Column store is better for tables that are subject to column operations and large number of rows, and that have large number of columns more unused, and that are subject to aggregations and intensive search operation for the column store. Even row store that contains many distinct values and low compression rates. Okay, so that is one advantage between, that is the difference between your row store and column store. Okay, so first I have shown you how to identify the row store and column store. First is what, with icons itself you can understand that this is a column store because it is horizontally there, vertically there, and this is horizontal. Second, when you go for the table design, then you can see here the table type will be column store here, and this will be your row store data. Cool. Now if you want to make this T1 as a row store, then although there is a data here, right? Now when I go for T1, and now I'll try to execute. So the data which is executed output of this, and T1 is what, it's a column store data. If you want to change this to your row store, then you can give it as alter table. What is the table name? That is orders underscore T1. You can drag and drop here. Then after that you can put it as row store. You can give it as just row. So you want to alter this table from column to row store here. Now select only this table, sentence, and click on execute. So successfully executed. Now we'll try to refresh the table again. Now if you see the icon here, now it is also a row store now. Or if I go for T1 now and go for refresh, I'll close down and refresh now. You can see this is a type of data is a row store data. Now the last time which I executed, the first one is T1, general SQL statement. Now if I again execute it, the same type of data has been displayed. So output you will not be able to identify whether it is in column or store, right? But only thing is by the structure you'll be able to understand it. Now from row store, now column, currently this is a row store. If you want to change back to your column store, you have to give it as, if by chance initially you created this as row store and you want to change this to column store, then you have to give it as alter table, the table name space your column, type of table is column store, and click on execute. So it's because now I not selected this, so first executed this statement, you are able to see this. After that it has executed this statement also. Now let us go for or we'll try to change this table of T2 also, because initially it is row store. Now I'm trying to convert this into column store. Now both are column store, and I'll try to refresh now. So T1 is a column store here, you can see this, and T2 also is a column store table here. Okay, so this is how we try to alter the tables from column to store, or row store, and row store to column store. By default, system creates a row store if you don't specify it as a column store table. Okay, now second important concept in your column store table is, now if I try to insert the data into your table, then it takes some time for, right, it delays for the insertion of the data. So what SAP has done is, in a column store table itself, I'll take like this, in a column store table itself, when one column store table, we'll have two more tables, that is your main table and delta table. So main table is a column store table which is compressed and read optimized as well as sorted, whereas your delta table is a uh, it's a row table type, so which is mainly used for your write operations. And when you do a select statement on this table, for example, last time we have taken as orders underscore T1, right? So this is your orders underscore T1 is a, for example, T2 is a row store table, or T1 is a column store table. So in a column store table, one orders underscore T1 will have two tables inside. One is main table and delta table. So we want that the data, whatever is being committed during your insert operation, that should be written directly to your delta table. As this is a row table, the data will be written faster. There will not be any delays like your column table. Now, for example, if the data of this delta is being reached up to 1 GB of data, then I don't want to, for every single record, I don't want the data to be committed to your main table. So after 1 GB storage of this row store table, it keep on committing it. Finally, it will try to throw all the data into your main storage. So this concept of merging the data from your row store table to your column store table, we call this as an delta merge concept. Okay, so whenever you're reading the data, then it will be reading from both the tables, that is your main table and delta table. Got it? By this, what is happening is, we know that we have a demerit of having a column store data. When you have a lot of inserts happening, then the data will take a lot of time for this. So we don't want this to happen. So we're trying to have one more table, temporary table, which will be called as an delta table. Now say for example, I'll take like this. For example, I'll take like this. Just I created one table, right? In the previous section, I created one table here. So this table, I'll call this as orders underscore T1. So what type of table is this? This is a column store table. Got it? Orders underscore T1 is a column store table. Graphically, we understand that this is one column, this is another column. So like this, we have different columns inside this. Now I'll take like this. Column store data, for example, if it is plant or country, plant, storage location, material group, material. Then after that I have quantity, price, and amount. So country, plant, storage location, material, this. Now this all things are called as attributes, right? So I'll try to put this as attributes, and this all numerical data, quantity, price always will be there. So you have to distinguish this as your measure. Now column store data normally will be stored. This is country is one column here. Okay. So this is one column. Plant is another column. Store location is another column. So like this, every column in a column store table is different here. But all the data of all your columns, I'll take this also as another column. Right, there are different columns here, and these are also separate columns. Again, quantity will be another column here, so we should not neglect this one also. And this is another column. And this is one more column. Okay, so these are different columns what we have. But now in one particular table, but physically in this particular table, in one particular table, that is orders underscore T1, same table, we should think that there will be two more tables which will be there with the same structure. Okay, so this is one table what we have, and there will be another table what we have. So this many columns, 1 2 3 4 5 6 7 8. So 8 columns are there here also, and 8 columns are there here also, because both the table structure is same. Columns data as well as structure will be same. So this table is known as main table, and this table is known as delta table. Now what you're trying to do is you're trying to write some select statement here. What is a select star from orders underscore T1? Okay, so I'm trying to execute orders underscore T1, and you're trying to put some data here, right? So now this is all you have. Control D. I'll have this data here. Say normally whenever you go for insert statement, or I'll not go for select, first I should go for insert statement. Insert will be there here. So when you select, give this insert statement, so insert statement, when you're trying to do this, because always when you do the inserts, and finally we'll have for every statement we have to put commit. The second statement is commit. So commit means it will try to, the insert statement always will be in the memory first. After that it will be written permanently to the disk in Oracle and all. So once it is committed, that means it is permanently written to the disk. But normally when it is in the memory, if, for example, the data is lost and it is not committed, that means it is not gone to the disk. So after every insertion, modification or deletion, commit statement is important for us. But in our HANA Studio, we have this commit happening automatically. Okay. So for example, when I take this table, and when you go for the properties, view the properties pane of this. Let me go to your this views window. then show view, that is your property view. So you can see here in the select statement, when you're trying to do inserts and all, auto commit is on. Means every insert statement, modification, delete, automatically the commit will be permanently written to the database. If you put off in off, and although you have done this inserts and all, it will not be written directly permanently to your database. It is, all things will happen within the memory only. So commit important to us. So all the commits which are being done, that means when you put a commit statement, auto commit is done, then for every statement it will put commit, commit, commit. All commits will be given here. So when commits are done, that how many commits are there? So first is it will try to insert it, go for a commit. So once commit is done, then this record is inserted here, first record. Then second commit, this is recorded. So all the data will be first inserted into your, all this data will be first written to your delta table. Okay, all this data will be inserted into delta table. Now how many records do we have? For example, 11 records. So there will be 11 records here. Okay, now when I go for select statement, select star from orders underscore t1, then what it does is, always the select statement will read the data from this main table also, okay, as well as, for example, from the main table also, as well as from the delta table also. So currently whatever inserted first commit always goes into your row delta table. And delta table, what type of table is this? It's a row table. So row table will insert the data very faster, so we're trying to keep it here. But main table is a column table. Got it? Now here the main idea here, why I'm keeping a separate table here, because and every insert I'm not inserting directly into this particular column table is, for example, in the column table I have 10 years of data, and that is, say for example, 50 billion of data is there. Now this data is always sorted, the data is compressed, right? And there is huge volumes of data, 50 billions of data is there. Now for one insert, if what I'm doing one insert here, this insert, if I try to insert it directly into this particular, see from here, if I try to insert directly into this table, here if for 50 billion, within the 15 billion records, it has to search where it has to be positioned. And for second record also it has to be doing it. Say for example, if 11 records are there, so 11 times it has to sort it, again recompress it and see the position, so it will become huge delay in getting the data, and the reporting users will have a bad performance while reading the data when you're trying to put directly writing the data into your main table, because there is huge volumes of data. So what SAP has done is, they're not trying to insert the data directly into this, they're not disturbing this particular data, because end users will be utilizing this and they want the best performances to be reported. So for that, what happens is the commits will be done to your row store data. Now how many records are there here? 11 records only. Now initially when I go for this 11 records only, we'll forget about this one. When you go for select star from orders underscore t1, the data will be read from your column table also as well as delta table also, from both, union of both the tables. So there are 0 records here, there are 11 records here. So total output records will be 11 only, which will be displayed. So the idea is, say for example, let it is, for example, if the time has been reached to 1 hour, or for example 1 GB, or I can give some conditions, multiple conditions here. So 1 hour is reached. Now whatever the data is being collected within 1 hour, system will automatically transfer the data from delta table to your main table. Now say for example after 1 hour, then I got some 1000 records. So this 1000 records after 1 hour will be transferred to your particular column store table. Now if column store table has got say for example 1 lakh records. So instead of doing this commits and recompressing and sorting the data 1000 times, it will be done only one time. Merging will be done to your table. So it will become 1 lakh 1000 records. Only merge, and after that the data will be deleted. So in between, if you do it again, select statement, now it will do a union of both the things and read the data from this table as well as this table. Now currently it is 1 lakh 1000, here there is 0 records. Okay, or if you think that while reading the data it's not yet merged, it is there 1 lakh and 1000, when you do a select statement, it will be read, the data will be read from 1 lakh as well as 1000. Both the data combined will be able to see the output of it. Okay, so this concept of merging the data, transferring the data from your delta table to your main table, we call it as an delta merge concept. Is it fine? Any doubts in this? Yes. So any more doubts?
No, Ravi.
It's okay.
Yeah.
Yeah, Prasanna. Okay. So now, if I try to show the data now, table of a column store here. Okay. So, where's Shushma left off? Huh? So here, if I have a table called column store table, where is this? Okay, so when I go for this column store table, now thing is, I'll see here it's a row type of table, and come to the runtime information. So we'll not have any type of specification here. Okay, so here you can see total memory consumption is 194, the database consumption, number of entries is 11, and the size in the disk is now currently blank, it's not used. And we don't have main table or your delta table here for a row store. It is a simple directly like RDBMS, that table will be storing all the data in one table only. But if you see this as a column store table, this is a column store table. Now come to the information. Only in column store table, you will have two types of tables. That is your main store table, and another is your delta store table. Now the data what I have inserted 11 records is inserted into your delta store only. Okay. So now in the delta store, how much KB of data is there? So 193 KB of data is there, and here in the main store it is 1 KB. So whenever I do a select statement, when I do a select statement here from T2 or T1, right? From T1 I'm trying to read the data. then the 11 records will be read from both the tables, main storage as well as delta store. But currently there is no data there, so it will read from this particular place only. Okay, so we can give some threshold values. The basis will give the threshold values when this data has to be merged. Okay, so we can do a auto merge, or we can do it a manual merge also. If you want to do a manual merge, then what I should do is I can right click this particular table, go for perform merge, delta merge operation here. Okay, so when I click on perform delta merge, so it tells us the entries from this table will be put into the main table. Click on OK. So once you do this, that means immediately you want the data to be transferred from delta to the main table. Now refresh this. Try to take out T1. Go to your runtime information. 193. Still 193 here. Okay, I'll try to insert some more records. Okay, I inserted some multiple records there. Now when I try to refresh, now than 193 it should little bit increased, because when you're doing a commit insert operation and the commit is happening, then your main memory is being increased to 228 KB of data has been inserted. Now when I do a delta merge here, perform delta merge operation and refresh this, now you can see this has become 96 KB, because there will be some memory allocation for the space also. Okay, then after that from 1 it has been increased to 49 KB. You can see the number of entries is what, 44, and the total memory consumption is 145 KB, and in the hard disk it will be storing as 352. We cannot read this data, but this is only for the backup purpose. Okay, so this will be the concept of your delta merge operation, what will be happening. So in order to increase the writing operation, write operation, insert and DML statement operations within the column store data also. So what SAP has done is, internally they created for every column table, they have created a delta table as well as column table. Now for every commits, it will be happening in the delta table only, and whenever you merge it, then only the data will be put into your column store data. And after transferring the data here as 1000 records, then the data from this will be deleted. So that for every single operation, we don't want to disturb our main column data, because it is highly compressed for the performance. So only after a certain particular period or particular storage limit, the data will be merged to your column table. So this concept is known as delta merge operation. Okay. So we need to practice this. Okay. So tomorrow I'll give the server access and we can see the data there. I can see here the column operation, how it is happening. So column name, currency, and each column occupies certain particular limit, and you'll see that all these rows are what, 44, 44, 44. Okay. Now currently the database is filled with your data. Okay. Now we can see that the delta is already merged. So this operation, sometimes what happens is this delta merge operation fails and still the data is remaining in the row store only. Then we'll have a reporting performance slower. The data will be read, but only thing is performance will be slower for this. Okay, so fine. So only in this particular HANA, we'll be having two types of storages. One is your row store table as well as column store table. And if you see S4 HANA or S4 HANA, which is created by now currently what SAP is trying to create, simple finance and simple logistics. But internally, even though they are transaction tables, most of the tables, transaction tables will be created as column store table only. And your configuration tables, small tables, and where data is oftenly written or modifications happening, that will be created as a row store table. Like in PFCG, we have a lot of customization tables, right? So they all will be created as your row store tables, and your transaction tables like VBAK, VBAP, VBEP, all your tables will be created as a column store table. Because the main idea is the data may grow huge volumes, right? So even though it has gone to huge volumes, still we'll be able to report them data faster. We want to go for analytics also. So transactions also will be done as well as your reporting also will be done. Okay. Okay then guys. So shall we pack for today? So we'll catch up
Yeah.
tomorrow. Yeah. So I think today it got a little later. So and even the timings, I think in the time zone also is a little different in that. So I'll try to change that, and we'll start by tomorrow at 9 o'clock itself. Okay.
Yeah.
Okay then. And we'll see that Saturday and Sunday we'll meet up in the classroom. Okay, so that we can cover up a little faster, because our idea is during weekdays also we'll try to have these classes, and weekends in Saturday Sunday we'll try to cover at least 3 hours in a day, so that we'll be up to the track. Fine.
Yeah.
Okay then. Chalo then. See you guys. Bye
Yeah.
bye.
Yeah.
Yeah.
Yeah.